We're going to look at differentiating expressions in the form, equations in the form y equal to a x to the n. So a and n are real numbers, and it turns out here that as long as n's are non-zero, we get this. So even if n is zero, we get this result. Anyway, point is, n can be any number, okay, any real number. It doesn't have to be necessarily an integer. And the rule is that if y is equal to a n x, then dy dx equal to a n. So we multiply that by n, and then we drop the power by 1. Okay? Like I said, this is true for fractions. This is true for integers. Yeah, and that's the only cases you're going to get. We're just going to jump right into some examples. So if we have a polynomial, y is equal to 3x to the 4 plus 2x cubed plus x squared plus 4, then dy by dx, and you can differentiate each term separately. We multiply the 4, so we get 12 x cubed plus 6 x squared plus 2x. And then, like I was saying, this does work for 0 as well. This is essentially 4x to the 0. So if we multiply down with the 0, we just get 0. And it turns out that all constants differentiate to 0. Okay, so y is equal to just a, then dy by dx equal to 0. Right, there you go. The next thing we're going to look at is we're going to use this rule. And I remember I told you that the derivative at a point x gives the gradient. Well, if we take a straight line y equals mx plus c, we know the gradient's m, but I want to confirm that with some differentiation. So dy dx is equal to, well, here we take down the 1, then we move the power down. So now we've got 1 times m, x to the 0 is 1, so we get m, and then c is a constant, so we get 0. So dy dx, so that confirms that, verifies that in the case of the straight line, the derivative does give us the gradient at that point. Okay? Of course, the gradient's always m for straight lines. So let's say, and we're going to introduce the notion of stationary points with the graph y is equal to x squared. We know this is equal to this graph looks somewhat like this, okay? And dy dx using the rule is equal to 2x. And we want to know, we want to find the point at which the graph turns here. We know this is at 0, but we'll just do it using differentiation. Well, if you think at a point where a turning point like that, the gradient is equal to 0. So we set dy dx equal to 0. So if dy by dx is equal to 0, then the only solution to that is, so 2x is equal to 0, and that gives x is equal to 0. So x equals 0 is what we call a turning point. And we'll look more into turning points, stationary points, in the upcoming videos. Okay, so hopefully you did enjoy this video. If you did learn something new, please be sure to like the video. If you want to see more A-level further maths, and also at the moment we're doing a series on group theory if you're interested. So if you want to see any of those, please be sure to subscribe. But for now, that's it. Any questions, let me know down in the comments, and I hope to see you in the next one. Thank you.